Hello everyone, my name is Signolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it.
Okay, hello. Welcome back to our lessons to our video lessons on exponential functions. In this video, we are going to continue with our study of the exponential function, and we are going to focus on the next variation on the original standard form of our exponential function. Now, just to recap quickly, remember that the standard form is y is equal to a to the power of x. This form is what I like to call the original form. Okay, so this is what I like to call the original form. And we know that we can have different variations on this form to make our graph behave a certain way or different ways. Okay, the first variation that we studied was in the form of y is equal to b times a times a to the power of x, and we saw the effect of b. We saw that the effect of b on the graph, on the exponential graph, is that it is a scaling vector. Okay, it scales the graph either up or down by a factor of b. Okay, so all the y values that you get from your original graph, which is defined by a to the power of x, will be multiplied by a factor of b. Okay, and that is the influence of b, and we dedicated an entire video on studying that. Okay, the second form that we looked at was y is equal to a to the power of x plus c plus c. Okay, this can be plus or minus c. Okay, and this can be plus or minus b, right? So we saw that the effect of c on our graph is that it dictates the number of units that our graph shifts vertically in the vertical direction, right? If it's a negative, then our graph moves downwards. If it's a positive, then our graph moves upwards. Okay, but we also noted that it is not only just the graph that moves either upwards or downwards, but it's also the asymptote of the graph that moves up or down, the asymptote of the original graph. The original graph, remember, is a to the power of x, and it moves up or down. Okay, and we also looked at a combination of the two. We looked at a combination of the two where we had y is equal to b times a to the power of x. This was in the form of an example that we looked at in a previous video, plus or minus c. Okay, where it's basically just the two characteristics put in together, or the two variations looked at together and implemented on one graph. Okay, so we have the shift of the vertical shift of the graph and the asymptote, and we've got the scaling factor applied on the graph. And we also noted that you work from left to right, right? So you look at the original form first, and then you scale it by a factor of b, and then you shift it either up or down depending on the sign and the value there. Okay, so now in this video we're going to look at the third and last variation that I want us to look at. Okay, and that third and final variation on our exponential function is, if you've got a to the power of x, and let's call that there, plus or minus d. Okay, now for simplicity I'm just going to say plus d. Okay, but it can be minus as well. Okay, so what is the effect of that on the graph? Well, we're going to do the same thing that we did for the previous two variations, and we're going to use an example to get our answer. to get our information. Okay, so let's draw up two columns. Okay, in the first column, I'm going to have a, or let me just say, I'm going to have y is equal to a to the power of x. In the second column, I'm going to have y is equal to a to the power of x plus d, right? Plus d. Okay, and then I'm going to put in actual numbers. I'm going to use an example. I'm going to have y is equal to, so my a will be 2. That's my go-to example. That's the example that I always want to use. And I'm going to have here a is equal to 2 to the power of x plus 1. Okay, then I'm going to draw in a line there. Then I'm going to do that, and I'm going to do that, and I'm going to do that. Okay, so I'm going to have x here, y here, then I have x here, and y here. Okay, so what I'm going to do now is I'm just going to put in random values of x from -1 to 3, then from -1 to 3. Okay, these are my independent variable values, and then I'm going to find my dependent variable values, which are my values for y. Okay, so what's going to happen if I substitute these values into these respective equations? Well, if I start with x is equal to -1 and I substitute it into each of these equations, I will get 2 to the power of -1, right? Instead of x, I write in the value of x. Instead of the actual x, I write in the value of x. So that's going to be 2 to the power -1, and that is, we all know, equal to half. Okay, and then in this case, we're going to have 2 to the power of -1 plus 1, which is the same as 2 to the power of 0. Which is the same as 2 to the power of 0, which is the same as 1. Okay, now for the second one here, I'm going to have 2 to the power of 0, which is 1. Okay, and then here, I'm going to have 2 to the power of 0 plus 1, which is the same as 2 to the power of 1, which is the same as 2. Okay, so in this case here, I'm going to have 2 to the power of 1, which is the same as 2. And then here, I'm going to have 2 to the power of 1 plus 1, which is 2 to the power of 2, which is 2 times 2, which is 4. Then here, I'm going to have 2 to the power of 2, which is 4. Then here, I'm going to have 2 to the power of 2 plus 1, which is 2 to the power of 3, which is 8. So that's going to be 8. And then here I'm going to have 2 to the power of 3, which is 8. 2 to the power of 3 is 8. And here I'm going to have 2 to the power of 3 plus 1, which is 2 to the power of 4, which is 16. That's 16 there. Okay, now let us look at the influence of d on this equation. Okay, so let's study the influence of d. Let's look at the values of y that we got from this table. Okay, so when x is equal to -1, for the original equation we get 0.5, and here we get 1. Okay, let's move on. When x is equal to 0, we get 1 and 2. When x is equal to 1, we get 2 and 4. Then we get 4 and 8. Then we get 8 and 16. Now, what is happening here? You will notice that the values of y for the variation, for the amended equation, the values of y are 2 times the values of y for the original graph. So these values of y are 2 times these values of y. Okay, that's just an observation that I am making. Okay, let me just go back and remove all these blues. Okay, so those are 2 times the values. Now those are 2 times the values of y, but that still doesn't help us understand the actual relationship in terms of, because we added y here, we added 1 there, but then we're getting 2 times the values of those there. So let's just try to study this further so that we can get a bit more clarity. Let's actually sketch this out. Okay, let's actually sketch this out and see what actually happens. So I'm gonna draw out my Cartesian plane. Here's my Cartesian plane. Okay, this is my x, this is my y, and I know that my original graph looks like that. It's very important for you to remember the characteristics of your original graph. Your original graph has your y-intercept there at that point. Okay, your y-intercept is 0 and 1, which is there at that point, and your asymptote, which is your horizontal asymptote, is on your x-axis. I want you to remember that. Don't forget that. Okay, so now when it comes to the new graph, okay, so remember this is for y is equal to 2 to the power of x. Okay, now what about, let me just write it, what about y is equal to 2 to the power of x plus 1? Okay, so we've got our table there. Let's just sketch it out. Let's sketch this graph out. So when x is equal to 1, when x is equal to minus 1, the y value is equal to 1, right? Okay, so coming down here, we know that the y value is equal to 1. Okay, so let's do that. Let's say that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so for the new graph, when x is equal to minus 1, when x is equal to minus 1, that graph is equal to 1. Okay, that's what we got up here. When x is equal to minus 1, that the new graph is equal to positive 1. Okay, so let's do that. Positive 1, it's somewhere there. Okay, somewhere there. Right, now when x is equal to 0, when x is equal to 0, y is equal to 2. When x is equal to 0, y is equal to 2. So 2 is there, x is 0 is there. Okay, let's go on ahead and get the next point. When x is equal to 1, y is equal to 4. When x is equal to 1, y is equal to 4. 1, 2, 3, 4 is here. 1 is there, so that's about somewhere there. Okay, that's about somewhere there. Let's get to the next point. When x is equal to 2, y is equal to 8. Okay, that's actually off our graph now. So that's off our graph, but we can see what's happening here. So we've got our graph combining like that. Just I don't want to miss the graph combining like okay, so our graph is combining like that. Okay, so I've actually not drawn this out well enough. If I look at the original graph like that, it's not gonna look exactly like that. The shape is gonna stay exactly the same as this graph that I'm sketching right now, but I want you to notice something. I'm just gonna try to draw it a bit accurately. Just a bit accurately, so that this can make sense. Okay, this is a more accurate depiction of what the graphs will look like, a more accurate approximation. Okay, so I want you to notice something. Okay, I want you to notice something. The blue graph looks exactly the same as the black graph. The only difference with the blue graph is that it shifted to the left. It shifted to the left by 1 unit. Okay, it shifted to the left by 1 unit. So you've got your original graph in black, you've got your new graph with the variation in blue, and the graph in blue has been displaced to the left, right? It has been displaced to the left by 1 unit, and that is the effect of D. Okay, that is essentially the effect of that D there. So that D there represents your horizontal translation or your horizontal displacement of your graph. Okay, it tells you by how much your graph moves to the left or to the right, or it tells you how much your graph moves or displaces horizontally. Okay, depending on the sign, right? Let me illustrate that through examples, just to give it a bit more clarity. Let's use examples. Okay, so let's say you've got y is equal to 3 to the power of x plus 2. Well, you will tell me that the original portion of that graph is 3 to the power of x, and you know how to sketch 3 to the power of x, right? Even if you sketch it very quickly, you know how to sketch it. 3 to the power of x is going to look like that. Okay, it's going to look like that. Your horizontal asymptote or your asymptote is on your x-axis, and your y-intercept is 0 and 1. Okay, now what happens with the addition of the plus 2 there? What happens with the addition of this plus 2 there means you take this original graph and you move it to the left by 2 units. Now, if you have a plus there, you move to the left. Okay, if you have a negative, then you move to the right. So I know usually plus means you move to the right and then negative means you move to the left. In this case, you do the opposite. Plus means you move to the left and negative means you move to the right. Okay, so this is plus 2, and it means that you move your graph 2 units to the left. So this graph, every point on this graph, every single point, each and every single point on this graph will move 2 units to the left. Okay, so that point will move 2 units, 2 units, 2 units, 2 units, 2 units, all of that, 2 units to the left, up until your new graph looks something like that. Okay, your new graph will look something like that, and that's it. So your asymptote there will be that point there. Okay, so that point there will be the one that comes and intersects your y-axis. Hence your asymptote change. So not your asymptote, your intercept, your y-intercept changes. Okay, your y-intercept changes and is no longer 0 and 1 anymore. You'd have to actually calculate it by just substituting x is equal to 0 and solving. Okay, so let's do another example before I summarize. Say you've got y is equal to 4 to the, or let me just, okay, let's use 4. 3 to the power of x minus 1. Okay, so how would you sketch this graph? Well, remember to always look at your original graph. Your original graph in this case would be 3 to the power of x, right? That's 3 to the power of x. That's your original. Since 3 to the power of x is your original, you know that your original will look like that. Okay, your original looks like that, and you've got 0 and you've got 1 here. Remember, you work from left to right. Okay, so now you know that. Okay, so cool. I'm going to write that 4 out in blue to show that I'm working on it now. You know that you take the original and you scale it up by a factor of 4. Okay, when you scale it up by a factor of 4, you know that your graph will be up there somewhere. It'll be up there somewhere, and it will do that. Okay, now you still haven't included the negative 1. Once you've scaled it up by a factor of 4, you know that your asymptote there will be 0 and 4. We covered this in a previous video in detail. Visit the previous video if you have a hard time following what I'm doing. Okay, we covered it in the previous video. now that you've done this, I'm just gonna highlight the -1 in red. Now you can look at the -1. Remember what I said, the sign, the negative sign means you displace it to the right. Because it's a negative, you move it to the right. You move it to the right. Okay, I know it's counterintuitive, but you move it to the right. So you take this new graph in blue and you displace it, all the points, you displace them to the right by 1 unit. All of them, you displace them to the right by 1 unit. So what's going to happen is that this graph is going to be there. Okay, and this graph in red is going to be your final graph, and the rest of your graphs here, the graph in blue and the graphs in black, fall away, and this is going to be your final graph here. The graph in red is going to be your final graph. Okay, and then you can calculate the value of your intercept there by just substituting x is equal to 0. So if you substitute x is equal to 0, then you're going to have y is equal to 4 times 3 to the power of 0 minus 1. And then you can solve. So that's going to be 4 times 1 over 3, essentially. So that's 4 over 3. So your intercept there is going to be 4 over 3. Okay. So this is how you would solve this. This is how you would essentially solve this. Okay, you move from left to right and you implement each one of the variations and then you solve. Okay, now I want you to note a couple of things with this graph, with this variation. This is the variation that you're looking at, right? Remember, a to the power of x plus d. Okay, plus d. Remember with your original graph, remember that with your original graph, this is what you had. With the original graph, you've got this. You've got your y-intercept being 0 and 1, and you've got your asymptote lying on your x-axis. Your asymptote lies on your x-axis. Now, what does this variation change? Well, we noticed that with this variation, we either move to the left or to the right. Now, if we move to the left or to the right, what changes? What changes? So if your graph moves to the left or it moves to the right, shape stays the same, it moves to the right. Okay, what changes? Let me just draw it a bit more accurately. What changes? Well, the thing that changes is your y-intercept, because your graph intersects the y-axis at that point there. Your graph intersects the y-axis at that point there. Your graph intersects your y-axis at that point there, depending on whether your graph moves to the left or to the right. So you will agree with me that the y-intercept, the point on the y-axis which the graph passes through, changes. But what doesn't change? The asymptote doesn't change. So the asymptote stays the same for this variation. Okay, for this variation alone, your asymptote is still at y is equal to 0. Your asymptote is still on your x-axis. It does not change. But what changes is your y-intercept. So your y-intercept changes. Okay, remember when I started in the very beginning, my lesson on exponential functions, I mentioned two important characteristics of the exponential function. That's the y-intercept and that's the asymptote, where the asymptote is. Now, the asymptote stays at the point that you found it to be for the original graph. Okay, but then your y-intercept changes depending on whether your graph moves at all or moves to the left or moves to the right. Okay, so that is the influence of this variation. Now let's just quickly combine all three variations together. Okay, let's quickly combine all these variations together and sort of sum everything up so that we can see how to deal with all these variations when they're all in one equation. So let's say you've got 2 times 2 to the power of x minus 3. Okay, 3 plus 2. Okay, remember that all of these, remember from this equation, this long equation that looks complicated, The original part is that. It's the part that has x as an exponent. Okay, that's the original part. That's the part that I want you to know inside and out. Okay, that's the part whose characteristics I want you to know inside and out. So if I were to sketch that original on its own, you will agree with me that it looks like that. I'm going to sketch it in black. As a matter of fact, this is what I'm going to do. I'm going to erase that and that and that, and I'm going to write them in different colors. Okay, so the 2 there, I'm going to write in blue. The 2 there, I'm gonna, what was it? What was it? 2? Doesn't matter. I'll put in a 2 there, and then here I'll put on a 3 in purple. Okay, so here's what I'm gonna do. What I'm gonna do is I'm gonna focus on the black. The black is the original. Okay, after focusing on the original on the black, then I can move from left to right. Okay, so what I'm gonna do is I'm going to focus on the black first, and then, okay, so what I'm going to do is I'm going to focus on the black actually, and then I'm going to focus on the purple, then I'm going to focus on the blue, then I'm going to focus on the red. Okay, then I'm going to get my answer. So let's do that. I know that the black looks like that. Okay, without any calculations, without anything, I know that the black looks like that, and that's my y-intercept. Okay, there at that point. Cool. Now I can focus on the purple. Now, any operation that I do, I must do on the black, okay, on the latest graph that I have. So the latest graph that I have right now is the black graph. Now, what I'm going to do, I'm going to take the black graph and I'm going to move it to the right by 3 units. Okay, I'm going to take all of the points on the graph, all of the points on the graph, all of them, right? And I'm going to move them to the right by 3 units. So if I move them to the right by 3 units, this is what I'm going to have. The graph will move to the right by 3 units. Okay, it'll move to the right by 3 units, so the graph will be there somewhere. The graph will be there somewhere. Okay, now after doing that, after shifting it to the right by 3 units, I'm going to scale it up. I'm going to scale it up by 2 units. If I scale it up by 2 units, what's going to happen? Well, the y-intercept is going to become that value there, a factor. Okay, so you're going to take the y-intercept at that point, and then you're going to take that y-intercept and multiply it by 2. Okay, so basically you're going to take all the y values for this graph and multiply them by 2. So let's choose the blue ink there. So all these y values here, all of these y values that make up this purple graph are going to be multiplied by 2. Since all the y values are being multiplied by 2, they are going to go up by a factor of 2. Now, I don't know exactly where they're going to go. They might go above the original line, the original black graph, or they might not. Okay, then you're going to have your blue graph being at that point there. Okay, this is purely illustrative, showing how each of the variations affect the graph. Okay, I'm not drawing anything to scale. I'm not drawing, as you can tell, I'm drawing things very roughly. I'm sketching things, but I'm only illustrating the principle here. Okay, I'm not drawing stuff to scale. Okay, now that we've dealt with the blue, we can address the red. What does the red tell us? The red tells us to shift our graph upwards by 2 units, but not only just the graph, we want to shift the asymptote as well. So the asymptote is still here, right? The asymptote is still here, but we want to move it up by 2 units. Now, if I move it up by 2 units, say 1, 2 is up there somewhere, then my asymptote is going to be there somewhere. Then I take this graph, the blue graph, this graph, I take that blue graph and I also move it up by 2 units. Then my graph ends up somewhere there. So ultimately, what this thing is going to end up looking like is the graph in red. Okay, so everything else falls away and then the red stays. I'm going to redraw the asymptote. Just want to clear this first. Okay, so ultimately, this is what I'm going to have. Okay, this is my y-axis. Then my asymptote is going to be somewhere there. That's where my asymptote is going to be. Okay, because I shifted it up by 2 units with the graph. And ultimately, this is what my graph is going to look like. Now, if you sketch this in detail and you measure things nicely, you draw your Cartesian plane using rulers, and you demarcate your divisions nicely, you're going to end up with something much more accurate than this. But in principle, this is what you're going to end up with, and this is how each of the variations affect your exponential graph. Okay, so that's basically it for your exponential function. That's basically almost everything, if not everything, that you need to know about it, and the rest should come to you with practice. But yeah, as far as the exponential function goes, we've covered all the essential aspects of it. We've looked at the different variations, how they affect the graph, how to sketch the graph, and what each of them mean, and the implications, and all of that. And if I go back all the way to the beginning, uh, all the way to the beginning, these are the three variations that we looked at. Okay, these are the three variations that we looked at, and we looked at all of them, and we now understand all of them. And from now on, it's practice, practice, practice. Okay, till next time. Lesson number one, lesson number one. Lesson number one.